Hi, my name is Ben Owens, and in this video we are going to look at the conceptual idea of limits. So why do we study limits in calculus? Well, the formal definitions of the two main ideas in calculus, that is, differentiation and integration, both utilize limits. So what we want to do is to introduce limits on a conceptual level to help build an intuition into how these things operate. So the informal definition of a limit is this. The limit of f of x as x approaches c is L if f of x becomes arbitrarily close to a single number L as x approaches c from either side. That's kind of a mouthful. In notation, the same statement above is this. The limit as x approaches c of f of x is equal to L. Now let's look at some examples to see what this really means. In this example, we have the function f of x is equal to x squared plus 2, which is this quadratic function or parabola that's been shifted up by 2 units. Now, what we're trying to find is the limit as x approaches 1. So what we want to look at is where the y value is going as x approaches 1 from either side. So as x approaches 1 from either side, if we were to look at where the function is going, it looks like from the left it's going up to around 3, and from the right it's also going to 3. And so therefore, we would say that the limit as x approaches 1 of f of x is equal to 3. That is, as the x values get closer to 1 from either side, the y values get closer to 3. Here is a similar example. In fact, it's the same exact function as before, except at the point 1 itself, the function has a hole in it, and it's been defined up at 5. So let's look and see what the limit is here. Once again, as the x values get closer to 1, from the left, the y values are getting closer to 3. From the right, the y values are getting closer to 3. So therefore, the limit as x approaches 1 of f of x is 3. Now here is an important idea. When dealing with limits, it does not matter what happens at the point itself, only what happens close to the point. In other words, what is happening as you approach that x value, not at the x value itself. Let's take a look at this example. Here, I'm asking you to compute several limits. I'll give you about 15 seconds to think about what you think the answers might be. The first one is asking us to find the limit as x approaches 0. So we're going to look at what's happening around x equals 0. From the left, it looks like the function is heading towards 1 as we get closer to 0, and from the right, it looks like the function is heading also towards 1. So therefore, the limit as x approaches 0 of this function is 1. For the second one, the limit as x approaches 3, from the left-hand side, it looks like we're getting close to 0. And from the right-hand side, it looks like the y value is also getting close to 0. So therefore, the limit as x approaches 3 is 0. Notice that it doesn't matter that the function is defined as -1 at 3. For the next example, we would say that the limit here does not exist. The reason for this is that at -2, if we approach this from the left, it looks like the function is going towards 2. But if we approach it from the right, it looks like the function is going down to -1. In order for a limit to exist, or to be well defined, we need that these two values approach the same number. But in this case, they don't. So we would say that the limit as x approaches negative 2 does not exist. Finally, if we look at x is equal to 1, we're looking at the limit as the x values approach this value 1. From the left, it looks like it's getting pretty close to 1, and from the right, it looks like 1. So therefore, since those two agree, the limit as x approaches 1 is 1. So let's look at these questions to make sure that we have a good conceptual understanding of what's going on. The first question is, why is the limit as x approaches 3 not equal to negative 1? Here, we're talking about the limit as x approaches 3. Why is the limit here 0 and not negative 1? Well, remember, when we're talking about limits, we only care what happens close to the value 3, but not at the number 3 itself. So close to 3, it looks like this is approaching 0, not negative 1. In the second question, it asks, why is the limit as x approaches negative 2 not 2? In this case, the limit is not 2 because it doesn't approach the same value from either side. In order to have a limit, you must approach the same y value from either side. The same argument holds for question number 3. Here is another example. I'll give you about 20 seconds to think about what these answers should be. So the limit as x approaches 1 is going to be where the function is approaching as we get closer to 1. Well, in this case, the limit here is going to be 1. Now, the function itself is defined here above 1 at 2. So therefore, we would say that f of 1 is equal to 2. This notation is telling us, or it's asking us, where is the function when x is equal to 1? Or what is the y value exactly at the point 1? In the next example, we want to look and see what happens here around 2. So the limit, kind of as we come from the left, looks like it's going to 2. From the right, it looks like it's going to 3. Since these do not agree, since they're going to different places, we would say that the limit here does not exist. F of 2 is asking us to find where the function is evaluated at that point. Well, since the function is filled in at 2, then we would say that f of 2 is equal to 2. The limit as x approaches 3, it looks like the function is going down here and it will be at 1, so that is 1. And f of 3 is also 1. Finally, for the limit as x approaches 4, it looks like the function is approaching 2 from either side, from the left and the right. In this case, the function is not defined there, so f of 4, we would say, does not exist. Or you might say that the function is undefined at that point. So in summary, a limit tells us what is happening with the y values of a function as we approach a certain x value. It doesn't matter what happens at the point itself. Remember, limits only care about what happens around a certain x value, not at the x value itself. In order for a limit to exist, it must approach the same y value from either side. If not, we say the limit does not exist. I hope this video has been informative and helps you to create a better conceptual understanding of limits. Thanks for watching.